been meaning to talk about for a long time, and now we're finally going to talk about it. Great. Okay. Instructional shop. Who's right with? So the diversity assembly. So make sure to go. Why not? People are being bold and putting themselves out there, and you usually go and support them. Also, for what it's worth, Miss Parker is emceeing the assembly. And you guys all know Miss Parker, and she's great. Yeah.
Is it going to take up all?
It's flex, so most of your teachers are going to be down there anyway. Yeah.
Yep.
So there's that. And then the second thing, oh, that being said, first issue, I have to leave right at the bell. And then the third thing, and I'll be back. I gotta grab something for some of the coordinators.
It's all good. It's all good.
The other thing, you guys have, we're having our build day tomorrow, 9 to 3. Come on out. We'll be in the fenced area, so you'll just go straight to the fence. The school's locked, so you won't go through the school. You'll just meet us in the back, and we'll all go. Anything else? Questions, comments, concerns before we get going? Here's a general reminder, but please make sure your phones and headphones are put away. I will gladly take them if I see them in your hand, in your pocket, on your table. Don't want to see them. Okay? So even if your phone is sitting on your table, don't do that. All right, so let's get rolling. We are going to talk about, we're going to do a grand total of, I think 4. Okay. We're going to do a grand total of 4 examples today.
Oh.
All right? So right now we're going to do 4 examples. This first one I'm going to talk about, actually I'm not going to talk about this one. I'm going to talk about this under the lens of similarity, something that we all learned, we spent a lot of time on similarity last semester, and we're going to kind of continue that.
We're doing G3? Are we doing G3 on the test?
So, talking about
Are we
similarity.
doing G3?
For example, first example, just to remind yourself about similarity. Find the missing link. If these are 2 similar triangles, just give yourself a quick reminder of how similarity works. Again, what are we doing? Recheck in. First, work on it individually. Please get it written down. You guys have 1 minute. Possible. We're about to get cards. 30 seconds if you need it. Just double check. Like, what am I going to say? Here, tell me how to do it. Tell me how to do it. 30 seconds. Does everyone know what they're going to say? If I call your card, are you going to be able to tell me how to do this? Or at least, like, here's what my table kind of talked about. I'm not entirely sure. That's a fair answer. Just one. Yeah, I'm not really. Hey, Malachi's trying to choose someone he doesn't like.
Malachi forgot to choose me.
He's not. He didn't even look. He really didn't want to be. Jack of diamonds. All right, Josephine Dawson.
Should I just say how to do it?
Yeah, like how to do it, yeah.
Okay, so you want to find the scale factor between the 2 triangles. So you do 12 divided by 8.
And you get,
1.5.
so what do you do with that?
Then you times 5 times 1.5.
Awesome,
Well, you
so
do
you
the
get,
one side, you do the other.
awesome. So that 1.5 means that 8 times 1.5 is 12. And to do the same thing over here, 5 times 1.5
It's 7.5.
is what?
7.5.
Cool. So you get that x equals 7.5. Beautiful. Right? We've done a lot of work on similar triangles and shapes and in general. Okay, so here's where we're going, right? This is where we've talked about. You've seen these problems. We've ignored these problems a lot. We're not ignoring them any.
Okay. No, same thing. Exactly.
So,
Same thing for your answer.
now here's the deal.
Okay.
Ignoring what I just wrote. This is a fairly straightforward one. Ignoring what I just wrote, how long is that side going to be? Say one more time. 7. Okay, it sounds better. Some weird stuff happening over there. Right, because again, you can think about this a bunch of different ways, but 5 is half of 10, 7 is half of 14, or 10 divided by 2 is 5, and 14 divided by 2 is 7. This length right here has to be 7, right? We know this, we already know that, we know how to do these problems. That means that the expression underneath my thumb has to be equal to 7, right? It doesn't mean that x is 7, and it doesn't really mean, it means this side length is 7, so this x minus 4 has to be equal to 7, okay? So now we have an equation that we're going to solve, and we've all, I know all of you have solved equations before, and you have varying levels of comfort and expertise with it. Some of you feel like, oh, I can solve equations all day. Some of you feel like, ugh, I hated solving equations. Both are fine. We're going to work on them, okay? Of course, solving equations is all about doing the opposite operation. So what's the opposite of subtracting for? Adding. And then what's the most important rule with solving equations? Yeah. Both sides, the golden rule, treat one side how you want to be treated. I don't know. I'm not sure. But you add 4 to both sides, and you'll hear me say this a lot. Not that negative 4 and 4 cancel each other out. I don't really love that expression. These simplify. Technically, they simplify to 0. And what happens if you add 0? 0. Nothing happens, right? So that's the mathematical thing going on. So these simplify down to 0, and you're left with x is equal to 11. All right? So, again, we're going to talk about 3 different levels today. Level 1 is you're just kind of still working on similarity. Just ignore that expression and find out what that missing side is. Right? Because again, this 11 doesn't really represent anything in real life. And here's me being super fully honest with you, is the reason we didn't do this back in first semester is because it doesn't really have any importance to like our construction side of things. Okay? So the math I was really concerned with was that we understand similarity, and you guys have done so much similarity, and we're about to do some more with circles. That now we're going to start sprinkling in some algebra. The reason, full disclosure, the reason why we're starting it now, this last month of school, is to kind of give you some extra practice, because all of us are going into an algebra class in one form or another next year, right? So all of you will use this skill next year. So we're going to try and get better at it. That's me being super honest with why we're going to do it now. Okay, so we're going to kind of learn it through similarity. It will be part of G7. It will be part of the, 9, I lied, the circle stuff. It will be part of the circle stuff, just so you know. So the algebraic stuff, we're going to keep practicing. Again, I'll point out, some people have a real distaste towards like algebra or solving. If that's you, please remind yourself that it's not set in stone. It's not something you have to be bad at forever. You get better with practice. Okay, and that's all we're really doing here. All right, so that was our first example. That's the one I'm going to talk about the most. Let's do one that you're going to try on your own now, okay? Let's try, let me just highlight this though, again, to say that this side length was still 7. That was 7. And then we said that that x minus 4 had to equal 7. So we found a number that we could plug in there, okay? Next example. Again, I'm going to ask that you solve for x. This time we're going to use some fancy dancy trapezoids because why not? All right, I'll leave this up here as an example. Give this second one a shot. Yeah, they're similar, always similar, even though my drawings are terribly.
They're not bad, you just have to.
Yeah, absolutely.
If we're trying to find out this bottom length, so ignoring the expression at first, just trying to figure out, okay, how long is that again? Trying to figure out your multiplier. my multiplier, Meadow?
6 times 2 or 12 divided by 6.
Oh, going fancy. Okay. We're gonna do it Meadow's way. Meadow is using the ratio on the same trapezoid. So you said, give me what I multiply by. From 12.
What do you mean?
What 12 times what is 6?
2, no, 0.5.
There we go. 12, half, half. Oh, I went the wrong way.
Yeah, you went the wrong way.
I'm
It's
so silly. Meadow.
12 divided by
I'm also a master fixer. Okay, I'm sorry. So, yeah, you were right. You just ignore me at all times. Okay, 6 times 2 is 12, like Meadow said. Just listen to Meadow, you guys. She's not funny. Meadow, what else?
and then 8 times 2 is 16, which is how long that side length is.
Cool. So that side length is 16. Now, I like doing it that way, right? There's all kinds of the ratios among shapes. You can go within the same shape, or you can go, trans shape, like transatlantic, between the two shapes as well. Here, that works. The other thing I want to point out, a lot of you guys did this though. You did 8 divided by 6 to find out your multiplier, and you got 1.33. And then, just as a reminder though, when you use your multiplier, when you do 12 times 1.33, you need to make sure that you're using not the non-rounded answer. So you can either think of it as putting the answer, which is non-rounded, it's the full never-ending decimal, or you can go ahead and recognize that 1.33333 is a common fraction. 0.3333 is what fraction? 1/3. So write 1 in a third. In 1, there's how many thirds? 3. So 1 1/3 would be 4/3. So you could do 12 times 16, or you could do 12 times 4/3 to keep the number exact. Either way, of course, we get 16, and we can also use this other way to also get 16. Again, that doesn't mean that x is 16. It means that I'm looking for what number plus 5 is 16. Right? Which in our heads we can all say is 11. I can also show that algebraically. And here's me showing it algebraically. Right, x plus 5 is 16. So opposite of plus 5 is minus 5 to both sides, always and forever, so that we get our final answer. X then, whatever that was, would be 11. Alright, I told you we were doing 4 total. 3 done. 1 more to go.
I did algebra on the test on this.
Last one.
I'm sure you look like Joe, you're stupid.
Okay.
Cut your anger out now. Cut your anger out now.
Yeah, I'm just using it in the way of algebra. I've transformed it.
There you go. Stepping it up.
Is that 5 times x minus 2?
Sure is.
Okay.
Sure does.
Sure does.
Don't. Some people have probably Googled it. Yeah. Hey.
I got it.
I don't believe in everybody. I don't believe in you, and I also don't believe in you rooting the real for other people.
I was just explaining my interpretation.
Hey, shh, don't explain your injury. You know, you get it, okay? Some people, enjoy the process of learning and getting know what to root and like I can Where's the house? Sure does. It took me a minute. I'm just gonna keep it in mind. I understand. Hey, you're pretty dumb. Oh, I'm just kidding. I'm sorry. Shit, I'm not. Didn't I tell you? Wait, did I not tell you? Stop it! I'm trying to tell you something. Did I tell you guys this yesterday?
It's
I
like in
didn't- I
third
told
grade
third
and they
period.
said, you're stupid.
Here's what really almost, here's where my mind went. I'm just gonna full disclosure so you know that that was a little bit better than where my mind went. Every time you say something like that, what did you say?
It's pretty dumb.
It's pretty dumb. You know what I wanted to say? I was gonna say your mom's pretty dumb. But I didn't. I can't say that. But every every time you guys say something like that to me, at any time, I just want to be like, your mom's this and that. Like, but I shouldn't, and I know, and so I don't. So I just went with you are. I'm sorry.
I have the same response with your face.
Yeah, your
I was
face.
not gonna expect that.
Yeah, I don't know why. It's not appropriate, but it just do your best. Stop trying to.
Hopefully this.
Okay, man.
Okay.
Why is my handwriting? Get out of here. Right there, damn some Why are you popping into our conversation, huh? She knows out of here. She knows.
Salty, like you escalated very quickly with that. If you are thinking that's doing the most, like I was just getting the first step. Why are you throwing all these other weird numbers? Level 1 would be just freaking tell me how long that side is. I'm cool with that. That's a good spot to be in. All of us in here should be able to at least do that. Level 2 would be, hey, let's make this look like it did before. Let's ignore that 5, those parentheses, and just do it so it looks like the past 2 examples, because if you're just getting started and just getting comfortable with it, maybe I can change it up too much. So in the very least, here's level 2. Then we're figuring out that side length and then saying, all right, what if it was just x minus 2? What if you just ignore the rest of it? And then those of you who feel like you're feeling pretty savvy and like, oh, this is kind of easy and I feel good, do the whole thing. 3 levels. That's what we're getting to 3 levels today. Okay? So again, tell me that length first off, first and foremost. Second of all, tell me what x is if I had just written x minus 2. So that's the next step. Those of you who found the length, try and stretch yourself. Try and see, can we figure out what x would be? What's x minus 2? And those of you who feel real good, just do the whole thing. I'm going to give you guys another minute. I'd like you all at your table to have discussions and answers. 5 times x. People wrote 5 times x.
Okay.
That was confusing, right? You know how you write like 5 times 2. But then when we start talking about x, like, it gets weird. And some of you learn like, oh, check out this fancy thing. I can just use the dot. You know, like, oh, the dot means multiplication. But then, here's what happened. This here, the dot, was just too much. Like, it was doing the most, you know? So, mathematicians got increasingly lazy, and instead of even writing the dot, just smushed them together, and said that means multiplication. Okay? So some people, maybe you're listening right now and you're like, oh, that's great to know. I never really knew. I've come across that some people have like, I don't know, why are the numbers smushed together? And if that's you, awesome. Right? This is, again, am I spelling this right?
Depends on what you're writing.
You see what you're writing.
The evolution of X. A lecture by Felix Wilson.
I did not have that kind of time right now.
So, you guys, I'm just going to make like a 30-second TED talk right there. So again, there's a times in there. It's invisible. It's hidden. The opposite of multiplying is dividing. So we go ahead and say, awesome. Divide both sides by x. Just kidding, by 5. And you get x equals 7. X equals 7.
I am Benjamin.
All the way? Good. Did you tell me that already? You're leaving?
Oh, yeah, I did tell you that. And
Yes.
my best friend.
And you told me that we have to sign a thing for her.
Oh, and I was like, eh. Yeah, it's not 1:30 yet. Did you sign the thing?
No, yeah.
I didn't even hear about the thing.
Stop being distracted. All right. You guys, just ignore Meadow. She likes it. Okay. All right. Okay. Hold on. 2 things. Okay. So that's the version 1 way to do it. And that's probably the way you've learned maybe to do it. The version 2 way, some of you might have done it this way, where you were like, hey, I know that 5 outside parentheses means times. I know that means times on the weekend. Bye. And so what's the opposite? Opposite of multiplying by 5. Divided by 5. So right here, you're also allowed to divide by 5 at that step. divide by 5 at that step. And again, this 5 over 5 simplifies. What's 5 divided by 5? 5. Hey, Stevie. 5 divided by 5 is 1. So you're left with x minus 2 is equal to 5. So again, opposite of adding 2 or subtracting 2 is adding 2. And either way you do it, we get the answer of x equals 7. Now, the last thing I'll say, my big rule for solving equations is that you should always know whether you are right or wrong. You should always know whether you are right or wrong. You should, might get an answer, and you should at least be able to be like, I got this, it's wrong. Maybe I don't know why, but I at least am aware that it's wrong. Because here's what that 7 means. Right? That 7 means if I plug it back in here, I'm looking for, this equation says I'm looking for some number that when I got my number x, and I subtract 2 from it, and then multiply it by 5, I should get 25. Alright, that's what this is saying. So I can check, because if I put 7 in right there, what's 7 minus 2? 5. 5, and 5 times 5? 25. Right, so we're good. Let's try sassy. Alright. Okay, so that's that. Here's what we're going to do. You guys are going to take your test.
Oh yeah,
You are going to put your notes away. In the calculator.
so long.
Can we listen to music? When you're done, I believe.